Welcome to Software Testing Unleashed, the podcast for testers, developers, and software makers who live quality as an attitude. Get fresh ideas and sharp insights to grow your mindset, to learn new methods, and to drive real change in how we build software. Better software and better teams for a better world. Hi, I'm Richie, software quality coach, keynote speaker, and book author. My guest today is Nikhil Barthwal. Nikhil is an expert in decentralized systems. He's worked in both startups and large corporations, giving him a wide view of real-world complexity. He also mentors other startups and speaks regularly at international conferences. His talks cover cutting-edge topics like software quality and distributed systems. In short, Nikhil knows how to build systems that scale and survive in the real world. In this episode, we talked about property-based testing, a method to go beyond human imagination in software testing because of the huge possible combination of this method. How can a system test itself by generating its own test cases? What do you do when your test space grows into billions of combinations? And why do some of the most critical bugs show up after 17 exact steps? We explored how property-based testing helps uncover edge cases that humans miss. Nikhil explained it in a super practical way, from modeling and generators to shrinking tests for failures for humans to understand. You'll also hear his take on where his method reaches its limits and how to start using it step by step in your team. So now, enjoy the episode. Hi, Nikhil. Nice to have you on the show here in the podcast.
Absolutely. Thank you so much for having me.
Yeah, you're traveling a long way here to Frankfurt to the QS Tag.
Absolutely.
Yeah. And you already told me we'll combine it with some sightseeing and visiting Europe.
It's actually a beautiful place. Just for context, I actually spent childhood in Germany,
Okay.
which was way back. My father was actually a nuclear scientist, and in Jülich, it was at that time West Germany, right? Not East, so they were separate. Jülich is Deutsch for Schung for nuclear physics. I don't know German, so it's something like that.
Yeah.
And he was a scientist there for a few years. So I went to German kindergarten and I learned German. And I didn't know English. I only knew German. So it was kind of my first language. And then I forgot German because I came back. Since then, I have rarely ever spoken German.
Yeah.
But it's kind of, my mom is traveling with me. So she's like, yeah, we used to live there. We went to this place.
Okay,
it's like
great.
those memories coming back.
Yeah, that's great. So maybe you can reactivate your German language also.
I don't know if it's a good idea on a podcast because it would look really silly.
Yeah, we can do it in English, it's no problem. Yes. Yes, we are here on the QS Tag from Imbus, and you have a speech about property-based testing. And I read your abstract and thought, property-based testing is not a part I knew very specific, so I want to talk to you. Let's start. What is property-based testing?
Yeah. So let me start with giving a background of when we my area generally is web services, right? Large scale microservices. You have like thousands of services. Now you want to test them. The thing is, when you're testing 1,000 microservices, and they can behave in a certain way in the sense that one service fails, the failure passes to second one, and you don't actually know it until the fifth, sixth service fails. So cascading failure, right? The number of test cases that you want to test or number of failure modes of a distributed system is huge. Mm-hmm. So in a simple mathematical term, assume that you have n services, right? And certain failures occur when 2 or 3 more services kind of fail. So now by simple maths, it's like n cube, where n is, 1,000 maybe. So n cube becomes what? A billion, million, something like that. Mm-hmm. And you want to test all these. How do you test it? Mm-hmm. Are you going to write 1,000,000 test cases? That's where the idea of property-based testing comes. So the fundamental a proposition of property-based testing is when the system gets too complicated, it is not possible for humans to write every test cases. So rather, we want these test cases to be generated automatically. How do we generate them? We know what the behavior of the service is, right? So if we say that this is the behavior of the service, if you pass a certain class of input, we are expecting a certain class of output, a system can basically write test cases for you automatically that can generate thousands and thousands of combinations of these tests and automatically test them rather than you writing them.
Yeah.
Okay. So for example, in a very simple way, let's say you have services that request two inputs, A and B, and gives you an output A plus B. Sounds about very simple, right? You would write some test cases 0, 1, 2, 3, some negative numbers, positive numbers, all those things. And if those test cases pass, everything is great. But the problem is that in real life systems, you have buffer overflows, you have integer overflows. At a certain combination where you approach that edge, it might be a possibility that the service would fail because you had a buffer overflow, you had an integer overflow, right? How do you test those? So rather than testing that, you describe the property that, well, if I send A plus B and the output is C, then if I subtract C minus B, the output should be A, because if A plus B is equal to C, then C minus B is equal to A. So I can generate thousands and thousands of combination of A and B, right? Get the output, subtract B, and make sure it is A. So your test case is not actually going to be what you're writing, what input you're sending, which is what typically, how do you test, right? You have like, okay, this is my set of input in I1, I2, I3, expect the output O1, O2, O3. Rather, you describe your system, right?
Yeah.
So I have described my system that the property of this service is that if I take the output and if I take one of the inputs and I subtract, the answer would be the second input. I just describe this property. I don't tell anything else. It's the system's job to write these test cases. Now, this is a very simple example,
Yeah.
right? But in real life, things are not that simple. So typically, property-based testing consists of three components. You have a modeling language, which in this case is a simple equation, but in real life will be more complicated modeling languages. Now, we have a lot of formal mathematics to describe these systems, right? I use TLA plus, but there are a bunch of them. There's formal specification. So we describe these formal specifications. That's one component, right? Then we have a generator which will take the specification and will write the test cases for you. I'll find the violation. So now you found something is wrong if your test cases are failing. Then you have a third component called shrinker. Now, typically, because you're writing these test cases, and these test cases are, I would say, not super random, but intelligently generated from your specification, they can have long sequence of failure mode. So I'll give a real life example. A test was done on a Google level DB database or something like that. If you replicate 17 unique steps, there will be a bug. Which human can anticipate that these are the 17 steps that you do?
Yeah.
That will replicate all. Property-based testing was used, and within 1 hour, it found that bug. Right? Now, when it generates these test cases, generates a long sequence of test cases, right? So that's what the generator would do, and something goes wrong. You know something's wrong. But now for a human, if I give you a sequence of 17 steps and say, well, this is what the failure is, you'll be like, yeah, I don't know where exactly the failure is.
Yeah.
I mean, I understand there's a failure, but these are 17 steps. I don't know which of the 17 steps failed. So the third component is a reducer. What the reducer does is once you have found a fault, it actually kind of starts shrinking it and saying, okay, let me try to dig exactly where things failed. So now you have these three components. When I describe my system, I have a generator. You can write your own custom generator, or you can use a standard generator, right? I have this generator that takes this specification, generates these million complicated cases. These are machine readable, right? We generate these cases, we find these faults, and the shrinker will basically reduce these complicated test cases for a human test case and say, well, this is exactly where the problem is. That's how a property-based testing would work. And obviously, for every language, stack, framework, you have different kind of frameworks, right? That would be.
And these frameworks are which technology have they?
So there are a lot of them. Typically, there are some commercial, there are some open source. So there are frameworks for .NET. I actually have a very small demo for .NET framework, but I actually give a list. There are frameworks for Python. This concept started with a framework, with a tool called Quick Check, which was written in Haskell. And then this was ported to multiple languages, and now you have FSCheck for .NET, and you have like I think some Python, PyCheck, something. So for bunch of technology stacks and bunch of programming languages, you have these frameworks. So yeah, there's no like property-based testing is a concept of this is how you test a system, right? Implementation, different people have implemented it in a different way. So that's why there are multiple frameworks. Some people say, well, this is how we generate the test cases. This is how we produce it. Of course, there's a commercial tools available. I think Cubic, which is being used in automobiles because they are mission critical softwares, right? If the software fails, people die. So you want to be absolutely sure something everything works correctly.
So they are the main topic is, or the main goal is to make a very huge coverage of all these combinations. And to get more reliability also for the system.
Ultimately the goal is reliability. Reliability, bug-free, whatever you call it, they all converge to the same point. But the key idea is that go beyond the human imagination. When a human is writing a test case, there's a limit to a human, right? If you look at the whole branch of formal mathematics, not just for property-based testing, you could look at testing in other systems also, like formal mathematics. The whole thing is that the number of permutation and combination of things that can go wrong is huge, way beyond a human can imagine. So I'll give you a very different example for property-based testing. There's a branch of mathematics. There's a tool called TLA Plus that deals with concurrency. Now, what happens is that in concurrency systems, you have threads and you have locks and all these things, and things can go wrong. The problem with these systems is that these bugs are intermittent, right? Because a certain set of conditions, usually caused by external environments, have to happen before your system crash. So you run your unit test cases, everything will work. You run on your production integration test cases, everything is run. You run on production, everything runs for 2 months. The third month, the first day of the third month, it fails. Right? How do you test those cases? Right? So because this is intermittent, it may happen, it may not happen. How do you test it? So here you have the same thing, because the threads can operate in a very different way based on the situation, based on the environment, which may be different from the environment you're testing on. So that's where all the formal method comes in, is go beyond the human imagination. It creates a state space diagram of every possible moves, combinations, and then sees that if there's a thread deadlock here, if there's a concurrency issue, or what happens, and then can find out, well, this is a problem that you would have. And this particular one, TLA Plus, is actually being used by Amazon AWS, and there's an article I can point out. It's actually publicly available, or if you Google, I think AWS TLA Plus formal methods, they actually write a paper on it, or how AWS use these formal methods to uncover bugs which otherwise would cause the system to fail intermittently, not always. And basically the idea was that to fix that, you sometimes have to write a complete rewrite of your system, because if there is a fundamental problem in your design, then what do you do? Property-based testing is kind of the same thing other way around. Here in this example, I've described how you design a system and how you build it. And the property-based testing takes the same idea and says, okay, fine, I have a software that is working. How do I test it? But the key idea remains the same, that human imagination works to a certain point. Once you go out at the scale, the number of combinations of things that can go wrong is so huge that it is not practical for a human to think or implement those test cases.
So in this specific case, you design a model of all these points you can combine.
Describe your system is how I'm going to word it.
Because
for test to generate, it has to have some kind of specification, right? Property-based testing in simple form is you describe properties of your system. There is a property, right? So for example, let's say that if I'm designing an e-commerce system, say Amazon.com, right? And you can describe a property that every time a person makes a purchase, let's say I purchase a box of chocolates because I have a sweet tooth, I love chocolates, right? So every time I make a purchase, then from the inventory, if n is the number of chocolates that I've purchased from the inventory, before the transaction and after the transaction, the difference should be n because I've removed n chocolates from the inventory, right?
Yeah.
I'm also going to have a property of the system that my revenue for the Amazon has to increase by n into the price of the chocolate. So I am now describing properties of a system based on the transaction. Now you would say, what's the big deal? The big deal is that in real life systems, you are using eventual consistencies because it's multi-threaded systems, right? So in a simple system, if you were to implement, this is a very simple thing. You're unlikely to run into a problem, but that's not how the systems are implemented, right? Because these are distributed systems working in multiple databases and different data centers, right? It could happen that this property is true for one data center, but not on data center two. Right? So how do you test those conditions? So you are now describing the properties of the system.
Okay.
And the system is writing tests for you.
Okay. Yeah. This, so I understand it correct. For this, the properties you already mentioned for the putting the end part from the stock and pointing up the revenue, you go one step further out of the system and describe the system also with the data center properties.
Yeah.
Yeah.
So essentially, now here the thing is there's you could, if you're writing unit tests, see, how do you specify? There are multiple ways of specifying. You could have a specification at a service level or a function level. You can have a service at a system level.
Yeah.
If you specify at a service level, then that's typically what a unit test would be. But if you specify at a system level, that's an integration test.
Yeah.
Right? You could do both. And people usually do both.
Yeah.
Makes sense to do both.
And what do you think? Where are the limits, or where it's not good to use property-based testing?
I think the limits would be that certain tests tend to be destructive. For example, way back, and maybe things have better now, but way back I was actually working at BlackBerry. So when you test, it's actually a phone call that you're making for which you're being billed.
Yeah.
Right?
Yeah.
If you're writing millions and millions of test cases, then you're making million phone calls, right? And for those million phone calls, you're going to get a huge bill.
Yeah.
Right? The same thing is going to be true for if you're testing your system at, let's say, you're building a system on top of AWS and you're writing some tests that requires writing to storage and so on. You're being charged for all the resources that you're using for test cases.
Yeah.
And now you're writing like 1 million plus test cases automatically. So your costs can go out of control. So I would say property-based test cases are not good where the resources you're using for testing incurs a huge cost for you because it can spiral out of control.
Yeah. I understand. Yeah. And when somebody listens now and says, "Oh, I want to start with this too," do you have 1, 2, 3 tips from starting, and also 1 or 2 things we have to be aware of if we start?
I think there's a lot of information on the internet, and there's good reference in terms of books and internet. So I think these days information is quite cheaply available on the net. So depending on framework tools, if you search on the net, you'll probably get a lot of I actually did that. You get a lot of references. The key thing, and that's probably not like that's true for all test cases, not just for property based, is to always start small and then grow big. So I would say, okay, if I'm designing a distributed system, let me try with one service and see how it's practically is. And then, go on and go on and go on and expand my scope. It's just better to grow organically, because when you're writing any new tool in an organization, whether it is property-based testing, it's not just a programming thing, right? You have to make cultural changes. People think in a certain way. Now you're forcing them to think in a different way. It's not as simple as here is a new tool, write these 4 lines, right? you have to build that culture, the shift of mindset, right? So there's a cultural component to it. And then you have a large army of people in a large organization, right? Changing 1,000 people's mind, right? It's not that easy.
Yeah.
And I've worked on similar projects where we were working on not so much on testing and new build systems. And I had this shiny new build system and I was showcasing and nobody used it.
Yeah.
Why? Because they had skepticism, right? A very tough part of my job, actually, probably say toughest part of my job is not to write code. Toughest part of my job is convincing people to do that.
Yeah,
At the stage where I am, convincing people is a hard job.
Yeah,
And these are people like, I have 20 years of experience. I know what this is. What are you telling me?
Yeah.
Right? And now you have to deal with it. So generally, when you start small and grow big, and I'm not just talking about property-based testing. This is actually, even if you use kiosk testing or something like that, the principles still stay the same. That when you start small and grow big, if there are any risks of implementation, some roadblocks, you will find out early, right? The agile philosophy, fail fast. And also, if your tool is working for one service, then it probably will work for another service. It's easy for you to convince people. One thing that I've always tried is I always pick one customer in, like if you're working in a large organization, we have 50 teams, pick one team which is willing to cooperate with me, right? We'll have property-based testing. We have this new tool, whatever changes you're making, show them the value, and then let them go and preach those values to the other members of the team. Because here, when you're introducing a new technology, basically you are a seller and your developers are the customers. They have to buy that idea. Let's use property-based testing, right? And standard marketing, if some seller is telling you my product is great, the customer is like, he's going to say that, obviously.
Yes.
But when you get a recommendation from a fellow customer, oh, no, I use that product, it's awesome. Then you have a lot more confidence because obviously there's a conflict of interest, right? I would want you to buy my service. So I'm going to say good things about it anyway, even if it's shitty.
Yeah.
Right? So that organic growth has to be there in a large organization. If you're using like from a learning perspective, that's a whole different story.
If you, I think one major topic can be in a team or in an organization. If you have all this stuff of combinations and this formal description, there is much more test cases than I can understand. So how do you deal with the topic of trusting all this stuff who gets out of the tools?
I'm not clear about your
question. So normally a tester has his test cases and they are very clear, one step after another, and I know what they do and I can check them, and that are my things. So I trust these test cases I designed. With this property-based testing with a lot of combinations who run, and I don't even maybe see them all. So how can I trust them?
When you run a property-based tool, you actually get, when the test case fail, you actually get a complete sequence of what happened. So there you can actually see if it's a valid one. You can write a test case for that specific one.
Okay.
Right? I mean, there are millions of things that can go wrong. I agree that in certain cases, there's a possibility that there are false negatives, right? That it actually is not a failure, but it's maybe a bug in how you described your system.
Yeah.
That can happen.
Yeah.
Right. So the thing is, you can and you should verify that the failure that happened, is it actually a failure? Right.
Yeah.
So what the system is doing is it's kind of not so much replacing a tester, more than it's assisting a tester. So a million things can go wrong. A human can't comprehend. So what the system has done is from those million, it has picked these are the 20 things that could potentially go wrong. Then I, as a human, I don't have to go through all the million combinations. I just focus on the 20. Now, in those 20, it could be that some of them are false negatives. But there's always a human supervision because once you begin, okay, this is something that has failed, I have to fix it. You first have to understand what is happening. And this is where the role of the shrinker is. I mean, that's exactly what the shrinker is trying to tell you. It is trying to tell you exactly where things went wrong.
Yeah. I think this is the shift to see it as an assistant for the tester.
Exactly.
Yeah.
So, separate from property-based testing, with all this generative AI, there's a lot of
Yeah.
debate on humans are going to be replaced. I'm like, humans are not going to be replaced. AI is not replacing humans. It's assisting humans
Yeah.
in become more productive. And that's exactly what property-based testings are doing for you.
Yeah.
It's just making you more productive, not replacing you.
Yeah, yeah. A great topic. Thank you very much, Nikhil. It was very interesting for me. Such a new topic for me too. So I have a lot of questions. So thank you very much to give us this insight. We'll put some information. Maybe you have some tips and references we can put in the show notes so everybody can read
Absolutely,
articles if there are a lot. And yeah, I wish you a good time here at the QS and a good speech afterwards and a good time in Europe for traveling.
Absolutely. I look forward to it quite a lot.
Yeah, thank you very much to be here.
Thank you.
Thank you. Bye.
Bye-bye.